Now next is logarithmic differentiation. Now logarithmic differentiation is used only when it is variable raised per variable form, or you can say that function raised per function form, or the multiple functions are involved. That is, if it is of the form, let's say y raised to power, say it is any function fx, or it is fx raised to power some function, that is your fx, then only we apply the logarithmic differentiation. Or the multiple functions are involved. If so many functions are involved, then we take the help of logs to differentiate them. So today's topic is, we are going to discuss, that is everything relating to logarithmic differentiation. So for example, the first question is how to differentiate x raised per x. You can see that it is variable raised per variable form, function raised per function form. So let us suppose y is equal to this. Now taking log on both the sides, so we have log of y is equal to log of x raised per x. So this can be written as x log x, because log of m raised per n is n log m. Now differentiating both sides with respect to x. So differentiating with respect to x on both the sides. So what do we have? It is d over dx of log y is equal to, it is d over dx of x log x. So differential of log y is 1 over y into dy over dx is equal to first function into the differential of second function plus second function into the differential of first. What is that? X into 1 over x plus log of x into 1, which is your 1 plus log x. Since we want to find dy over dx, so this implies cross multiplying y from here, it is y into 1 plus log x, or it is x raised to power x into 1 plus log x here. So this is one way to use the logarithmic differentiation, that is whenever it is function raised per function form or variable raised per variable. Now if I have to differentiate this question, what is the other way out? Other way out is, we have let y is equal to x raised per x. So this can always be written as e raised per log of x raised per x here. Why? It is to the base e, because e raised per log of a to the base e is equal to a. So ultimately it is going to be equal to that is your x raised per x here. So can this be written as e raised per x log x? So now differentiate this. So dy over dx is equal to, it is d over dx of e raised per x log x, which is your e raised per x log x into derivative of x log of x. So it can be written as e raised per log of x raised per x, this will go to the power, into first function into differential of second plus second function into differential of first. It is x raised per x into 1 plus log x here. So you can see here it is x raised per x into 1 plus log x. So both these methods are applicable to use the logarithmic differentiation. So in whichever method you are comfortable, you can use that method. Now, but I will advise you should be good in both these methods. So maybe in certain questions, certain method will be more likely to be applicable to find the differential of the function here. So you should be very particular about both these methods. So let us discuss more of the questions of this type. Now, next one is Say we want to differentiate sin x raised to power log x. Again you can see that variable raised to power variable form, function raised to power function. Always we will let y to be equal to this. Now log of y is equal to log of sin x raised to power log x, which can be written as log x into log of sin x. Now differentiating with respect to x, we have, what is that, d over dx of log of y is equal to d over dx of log of x into log of sin x. Now here u into v, that is two different functions are involved. So it is 1 over y into d over dx of y is equal to first function into the differential of second plus second function into the differential of, that is your first function. So this is equal to log x into differential of log is 1 over sin x into derivative of sin x plus log of sin x into derivative of log x, which is your 1 over x. So this implies dy over dx is equal to y into log x into 1 over sin x into cos x plus log of sin x into 1 over x. So this is your differential of this function. Ultimately we will replace y with sin x raised to power log x into log x into cot x plus log of sin x into 1 over x here. So this way you can differentiate the function using the logarithmic differentiation. Now for example the next one is x raised to power x raised to power x. So again let y is equal to this, log of y is equal to, what is that, log of x raised to power x raised to power x. Can this be written as x raised to power x into log x? So how this question is different from the previous questions, you can see that still it is variable raised to power variable form. That means again taking log on both the sides. So we have log of y is equal to log of x raised to power x into log of x. What is that? It is log of x raised to power x plus log of log x. Log m, n is log m plus log n. So this is equal to, it is x log x plus log of log x. What is that? It is log of log y. Now differentiating with respect to x on both the sides. So it is 1 over log y into d over dx of, what is that? It is log of y. First the differential of log y is 1 over log y into the differential of log y. Here it is d over dx of x log x plus d over dx of log x. So what is that? It is 1 over log y into 1 over y into dy over dx is first function into the differential of second plus second function into differential of first plus 1 over log x into 1 over x. So what is that? Dy over dx is equal to y into log y into, what is that? It is 1 plus log x plus 1 over x log x. So what is y here? Y is x raised to power x raised to power x. What is log y? Log y is, what is that? It is into x raised to power x log x into 1 plus log x, so plus 1 over x log x. So this question was a little bit different from your previous questions here. Now almost similar to this question is So that is differentiating x raised per x raised per x. Now the bracket is put here, which means let y is equal to this, log of y is equal to log of x raised per x whole raised per x. It is x log of x raised per x. So what is the difference here? Still log of m raised per n. Now it is x square log x. There is no need to take another log, straight away you can differentiate this function and you will be able to get the answer. This is the only difference between this question and the previous question. That is, it is x raised per x whole raised per, this bracket is put here, whole raised per x. Now next one is, let's say we want to differentiate log of x raised per x plus, what is that? It is x raised per log x. Now how to differentiate when it is sum or difference of the two functions which are written in the form of variable raised per variable here. Let us take y is equal to this here. Now easiest way, particularly for these type of questions, is that it is e raised per log of log x raised per x plus e raised per log of x raised per log x. Now can this be written as e raised per x log of log x plus e raised per log x into log x? So this is y. What will be dy over dx? It is e raised per x log of log x into d over dx of x log of log x plus it is e raised per log x whole square into d over dx of log x whole square. What next? It is, can this be written as e raised per log of log x raised per x into first function into the derivative of second function plus second function into the derivative of first plus, what is that? It is okay, I will again change this and write this as e raised to power, what is that? It is log x raised to power log x into the derivative of this 2 times log x into 1 over x into 1 over x. So what next? Can I write this as log x raised per x? Because e raised to power log of x to the base e is x into, this will cancel, 1 over log x plus log of log x into 1 plus, can I write this as, what is that? E raised to power, this is your log of x raised to power log x. So it is x raised to power log x into 2 log x into 1 over x. So this is the answer of this particular question here. Because e raised per log of x raised per log x is equal to, what is that? X raised per log x here. Now what is the other way of to solve this type of question? Now other way out is, let us take, we have y is equal to log of x raised per x plus x raised per log x. Let us say this is equal to u plus v. Now we know that dy over dx is equal to du over dx plus dv over dx. This is first. What is u? U is equal to log x raised per x. So taking log on both the sides, it is log of log x raised per x, which means that it is x log of log x here. So differentiating on both the sides, we have 1 over u into du over dx is equal to first function into the differential of second plus second function into the differential of first. So this implies du over dx comes out to be u into 1 over log x plus log of log x, which is your, what is u? It is log x raised to power x into 1 over log x plus log of log x here. So it is log x raised to power x 1 over log x plus log of log x here. So let's say this is your number 2. What is v here? V is x raised to power log x. Log of v is equal to log of x raised to power log x. Can I write this as log of x into log of x? So that means this becomes log of x square. So 1 over v into dv over dx is equal to, what is that? It is 2 log x into 1 over x. So this implies that dv over dx is equal to x raised to power log x into what is that? 2 log x into 1 over x. So it is x raised to power log x into 2 log x into 1 over x. So from first, second and third we have the required differential, which is same as which we obtained in the previous method here. So this is the other way to solve the same question here, right? Now next is, let's say we have the function which is your y is equal to under root of 1 minus x square into 2x minus 3 raised to power 1 by 2 upon, this is your x square plus 2 raised to power, this is your 2 by 3 here. So as discussed earlier, where do we use logarithmic differentiation? There are two cases: when it is variable raised to power variable form or function raised to power function, and another method is when multiple functions are involved. You can see that multiple functions are involved. Now what to do? So you taking log on both the sides. Now after taking log, you will find that this question will become very easy. So log of y is equal to log of under root of 1 minus x square into 2x minus 3 raised to power 1 by 2 upon x square plus 2 raised to power 2 by 3, which is of the form log m by n. So it is log of under root of 1 minus x square into 2x minus 3 raised to power 1 by 2 minus log of x square plus 2 raised to power 2 by 3. So this can be written as log of under root of 1 minus x square plus log of 2x minus 3 raised to power half minus 2 by 3 times log of x square plus 2. So what next? It is m log of n plus n log of m minus 2 by 3 times log of x square plus 2. Now differentiating both sides. So differentiating, we have 1 over y into dy over dx is equal to 1 over 2 into 1 over 1 minus x square into d over dx of 1 minus x square plus 1 over 2 into 1 over 2x minus 3 into d over dx of 2x minus 3 minus 2 by 3 into 1 over x square plus 2 into d over dx of x square plus 2. So you can see here it is half of 1 over 1 minus x square into minus 2x plus 1 over 2 into 1 over 2x minus 3 into 2 minus 2 by 3 into 1 over x square plus 2 into 2x here. So this way we have the differential. So what is dy over dx? It is y into minus x over 1 minus x square. Now plus 1 over 2x minus 3 minus 4 by 3x into x square plus 2 here. So this is the way to solve the to find the definition of a function when multiple functions are involved in the function here. Now another example of this is, for example, it is, let y is equal to e raised power ax secant x into log x upon under root of 1 minus 2x. Some of you might try to solve this question on the basis of u upon v formula or the quotient rule, but frankly telling you, if you take log on both the sides, this question is going to be very easy here. So taking log on both the sides, log of y is equal to log of e raised power ax secant x log x upon what is that? It is under root of 1 minus 2x here. So this is log of the function. Can I write this as log of e raised power ax and plus log of secant x plus log of log x minus log of under root of 1 minus 2x. I have used both the properties, that is, because log of mn is log m plus log n and log of m by n is log m minus log of n. So I've used both these properties. So can this be written as, because it is ax plus log of secant x plus log of log x minus half of log of 1 minus 2x. So if you differentiate now both the sides, we have 1 over y into dy over dx. This is equal to a plus 1 over secant x into the differential of secant x plus 1 over log x into the differential of log x minus 1 over 2 into 1 minus 2x into the differential of 1 minus 2x. So what is that? It is a plus 1 over secant x into secant x tan x. This factor will cancel, plus 1 over log x into 1 over x minus 1 over 2 into 1 minus 2x into minus 2. Sorry, it is minus 2 here. So this will cancel. What is that? So dy over dx is equal to y into a plus tan x plus 1 over x log x plus it is 1 over 1 minus 2x. So this is the differential of a function when the multiple functions are involved here. Now another question is, for example, it is given that cos x by 2 into cos of x by 4 into cos of what is that, x by 8 and so on is equal to sin x upon x. And what we have to prove here is, that is your 1 over 2 square secant square x by 2 plus 1 over 2 raised to power 4 secant square x by 4 and so on is equal to, this is your secant square x minus 1 over x square. So this is what we have to prove here. You can see that multiplication of infinite terms is there. So the only possibility is to take the log, and further you can see that what we have to prove here is addition sign is there. So which is possible only that if we take the log on both the sides and then applying the property of log mn is equal to log m plus log n. So taking log on both the sides, log cos x by 2 plus log cos x by 4 plus log cos x by 8 and so on up to infinity is equal to log sin x over x, which is your log of sin x minus log of x. Now differentiating with respect to x on both the sides. So it is 1 over cos x by 2 into differential of cos x by 2 plus 1 over cos x by 4 into differential of cos x by 4 plus 1 over cos x by 8 into differential of cos x by 8 and so on is equal to 1 over sin x into the differential of sin x minus 1 over x. So it is 1 over cos x by 2 into differential of cos x by 2 is minus sin x by 2 into 1 by 2 plus 1 over cos x by 4 into minus sin x by 4 into 1 by 4 plus 1 over cos x by 8 into minus sin x by 8 into 1 by 8 and so on is equal to, this is 1 over sin x into cos x minus 1 over x. So you can see here, this implies that half of minus half of tan x by 2 minus 1 by 4 tan x by 4 minus 1 by 8 tan of x by 8 and so on is equal to cot x minus 1 over x. But what we have to prove here is it is in terms of secant square. So again, differentiating with respect to x, what is that? Minus half into secant square x by 2 into 1 by 2 minus 1 by 4 into secant square x by 4 into 1 by 4 minus 1 by 8 secant square x by 8 into 1 by 8 and so on is equal to minus cosecant square x plus 1 over x square. So taking negative sign common on both the sides, we have 1 over 2 square secant square x by 2 plus 1 over 4 square secant square x by 4 plus 1 over 8 square secant square x by 8 and so on is equal to cosecant square x minus 1 over x square. So these questions are going to be very helpful for those students who are preparing for their competitive exams, because these methods will definitely improve your brain or your thought process or thinking process. The way you think about the question and their solutions is definitely going to help you. Now next is for example, the question is, if x raised to power m into y raised to power n equals to 1. So what we have to prove here is that dy over dx is equal to, this is minus my upon nx. You might try to solve this question by using the product rule, that is u into v rule, but it will be more convenient if we take log on both the sides. So taking log on both the sides, we have log of x raised to power m into y raised to power n is equal to log 1, which is your 0. So it is log of x raised to power m plus log of y raised to power n is equal to 0. Now m log x plus n log y is equal to 0. So differentiating with respect to x on both the sides. So we have m into d over dx of log x plus n into d over dx of log y is equal to 0. That is m into 1 over x plus n over y into dy over dx. This is equal to 0. So this implies n over y into dy over dx is equal to minus m over x, or dy over dx is equal to minus my over nx. So whatever we want to prove here is the result here. This way you can prove the result.